Okay. Okay, now we're back. Day two of Advent of Code. I've got a nice gin and tonic with me here today, since it's the weekend. Mm. So, I've also had a little bit of fun with the setup. So, this one. Now I have, oh, wait. There we go. Now I have a little Nim crown Christmas decoration going on here. Um, Someone asked me why I didn't put the crown lower down in my presentations. If you've ever seen any of my presentations, I typically have a crown in the top right corner. Um, and this is now I have one. Wait, this way. That's a video thumbnail if I ever saw one. Mm. But yeah, let's get into it. I'm gonna turn this off because that's probably gonna be very annoying, mostly for you guys. Right. So let's get into it. Here we have the day two puzzle. I've also, of course, created the day two folder. Oops. The day two folder, but nothing is here yet. Of course, and I haven't looked at these as usual. So yeah, day two, rock, paper, scissors. The elves begin to set up camp on the beach. To decide whose tent gets to be closest to the snack storage, a giant rock, paper, scissors tournament is already in progress. Rock, paper, scissors is a game between two players. Each game contains many rounds. In each round, the players each simultaneously choose one of rock, paper, or scissors using a hand shape. This might be a cultural thing, but do you really need to explain rock, paper, scissors to people? Then a winner for that round is selected. Rock defeats scissors, scissors defeat paper, and paper defeats rock. If both players choose the same shape, the round instead ends in a draw. Appreciative of your help yesterday, one elf gives you an encrypted strategy guide, which is my puzzle input, that they say will be sure to help you win. So, a strategy guide for rock, paper, scissors. Personally, I'm the kind of guy who goes rock first. Or, yeah, because scissors is the most common one to start with. So I usually go for rock. It's a free tip for you. There's a surprising amount of times in your life where you will come up with someone, you need to select something, and people go for rock, paper, scissors. So just having that tiny bit of knowledge can give you some nice perks. Yeah, so that's our puzzle input that they say will help you win. The first column is what your opponent is going to play. A for rock, B for paper, and C for scissors. The second column, suddenly, the elf is called away to help with someone's tent. Aha. So apparently this is encrypted. My opponent is going to play... We know what our opponent is going to play, which is really all we need to know how to beat them. Yeah, the second column you reason must be what you should play in response. X for rock, Y for paper, and Z for scissors. Winning every time would be suspicious, so the responses must have been carefully chosen. Aha. So that's where this gets interesting. The winner of the whole tournament is the player with the highest score. So it's not a beating everyone sort of tournament style, or I thought that was a tournament. What do you call that? Gauntlet? No. Anyways, the winner of the whole tournament is the player with the highest score. Your total score is the sum of your scores for each round. The score for a single round is the score for the shape you selected, 1 for rock, 2 for paper, and 3 for scissors. That's a weird way to score those. Plus the score for the outcome of the round. 0 if you lost, 3 if the round was a draw, and 6 if you won. It's a really weird scoring system. Since you can't be sure if the elf is trying to help you or trick you, you should calculate the score you would get if you were to follow the strategy guide. For example, suppose you were giving the following strategy guide, AY, BX, CZ. This strategy guide predicts and recommends the following. In the first round, your opponent will choose rock, which is an A, and you should choose paper. This ends in a win for you with a score of 8. 2 because we chose paper, 6 because we won. In the second round, your opponent will choose paper, and you should choose rock. This ends in a loss with a score of 1, because we picked rock, which is a 1. The third round is a draw with both players choosing scissors, giving you a score of 3 plus 3 equals 6. In this example, if you were to follow the strategy guide, you would get a total score of 15, 8 plus 1 plus 6. What would your total score be if everything goes exactly according to your strategy guide? So let's grab our puzzle input. Of course, again, quite a long input here. And these are, where's my save as thing? Save link as? Sure. Save that. So now we have our input here, and we want to do this calculation. So the easy part is figuring out these, because those are sort of hard-coded a score for the different ones. And then we also need to figure out who wins and who loses, which depends on, or wins, loses, and draws, which depends on the combination here. So there are a couple of ways of doing this. We could, of course, implement a procedure that compares these two and returns the value. We could also generate just a table of all possible combinations, because there's only, like, he can only choose 3, I can only choose 3, so that would be 9 possible combinations, I think. Yeah, it's a 3x3 grid, that's 9 combinations. So we could just create a table of these 9 combinations and then just compare each line to an entry in that table and sum up all those scores. I think that's probably the more interesting way of doing it. And we can show off the tables module. So we need a score table, which is a table from a string to an integer. And this is fairly new in NIM. I think even my solution for last year would have required something like this. But that is not the case anymore. And just an uninitialized variable of the table type will be a table, will be an empty table that you can add stuff to. Previously, it used to be that this would cause an error, but not anymore. So now we want to go, for opponent in A to C inclusive, yeah. And then for us, or for, I guess, player in X to Z. So since these are in order, we can do this. So we have X, Y, Z, A, B, C, X, Y, Z. This is iterating over ASCII ordinal values for a character. So this symbol here creates a character literal. If we had done this, it would have been a string literal. But for character literals, we can iterate over them. So in our score table, we can say that opponent and do string concatenation with a space and player. So what do we want the score to be equal to? So here we want to do two things. We want to have a value for the player. So this is the hard-coded 1 for rock, 2 for paper, and 3 for scissors. And we have, rock, paper, scissors, so X, Y, Z. Case of X, 1. Case of Z, X, Y, and Z. So that deals with our sort of base score. I guess we could even pop them in here. So what we can do is do a case of player like that. And then do 1 plus case of opponent. I think this might have to go in brackets. Case of opponent. So if we choose rock and the opponent chooses rock, then that would be a draw, and a draw is 3 points. If the opponent chooses paper and we choose rock, that would be a 0. And if the opponent chooses scissors and we choose rock, that would be a win for us. So we can grab this, just paste that in there. 2. So now we have paper, the opponent has a rock, so that means we lose. Oh no, wait, did I do this wrong? We have rock, opponent has rock, that's a draw. Opponent has paper, opponent has scissors, so that's right. We have paper. Let me annotate these for clarity. Rock, paper, scissors. And now we are in paper. And this is rock, paper, scissors. So we have paper, they have rock, we lose. Paper is a draw. We have paper, they have scissors. Oh, it should be this way. So we have paper, they have rock, then we win. Right. So scissors. That gives us a 3 base score. And if we have scissors and they have rock, we lose. If we have scissors and they have paper, we win. And if we have scissors and they have scissors, it's a draw. So that should create our score table. So in NIM, when you do Oh, and we need a, do we need, yeah, we need else clause for these. So in nim, pretty much every block statement returns their last value. So for example, a ternary in nim is something like this. It's just basically an inline if-else statement. But there's nothing special about this if-else statement. It's just a normal if-else statement. But every branch of the statement has to return a value of the same type. And the last value is just automatically done. So we could even do something like this. And then R0, and then do something like this, something else. And this X will now be 0 or 1, but we also have the side effect of printing something or else. So in this case, we create a case statement. It needs to have every case covered. So we have the case of X, the case of Y, the case of Z. Otherwise, we just return 0. This should never happen, of course. And then we just do the same thing in this inner case. We have our base value plus the return of this statement, which is either 063 or 0. And this will then be a number. And all of that will be returned and assigned in the score table. Pretty neat. So now we can just go over for a line in our input txt lines. So again, same from last time. You can also print out our score table. So here you can see it just prints out the whole table. We can also, if you go far enough up, I should have printed those at the bottom. Okay. It's easier, it's faster to do this than just scroll all the way up. So here we can see we have our table of scores. So CX, AX, BX, and these will match all our different possible lines. So AX is a 4. So what we can do now is we can have a score variable. And then for each line, simply add on the score from our score table with just a line. So a line will automatically strip off line endings, so you don't get a new line. Otherwise, this, of course, wouldn't match. And then we can echo out our score. That should be the solution to part 1. There we go. That's the right answer. You're 1 gold star closer to collecting enough star fruit. So, part 2. The elf finishes helping with the tent and sneaks back over to you. Anyway, the second column says how the round needs to end. So our assumption when he ran away was incorrect. Yeah, says how the round needs to end. X means you need to lose, Y means you need to end the round in a draw, and Z means you need to win. Good luck. The total score is still calculated in the same way, but now you need to figure out what shape to choose so the round ends as indicated. The example above now goes like this. In the first round, your opponent will choose rock, which is A, and you need the round to end in a draw. so you also choose rock. This gives you a score of 1 plus 3 equals 4. In the second round, your opponent will choose paper, and you choose rock, so you lose with a score of 1 plus 0 equals 1. In the third round, you will defeat your opponent's scissors with rock for a score of 1 plus 6 equals 7. Now that you're correctly decrypting the Ultra Top Secret Strategy Guide, you'll get a total score of 12 for the example input. Following the elf's instructions for the second column, what would your total score be if everything goes exactly according to your strategy guide? So, quite fascinatingly, this solution turns out that the solution we had for part 1 turns out to be better than the alternative solution I was talking about for this, because the website there incorrectly guessed that we need to figure out which thing or what we need to choose to win a game. All we need to do is to update our table of scores, which is interesting. So X means you need to lose, Y means you need to end the round in a draw, and Z means you need to win. So if X means if X means we need to lose, Y means a draw, and Z means a win. Just double check that, yep. So if our opponent chooses rock, of course, lose is 0, a draw is 3, and a win is 6. So if we need to lose against a rock, we need to choose paper. No, we need to choose scissors, and scissors is 3 points. But if we need to lose against paper, we need to choose rock, and rock is 1 point. And if we need to lose against scissors, we have to choose paper, and paper is 2 points. Remember the scoring here. Yeah, 1 point for rock, 2 points for paper, and 3 for scissors. So in a draw, we do, so to draw against a rock, we need to do a rock, and a rock is 1 point. If we need to draw against paper, we need to choose paper. And if we need to draw against scissors, we choose scissors. To win, if we want to win against rock, we need to choose paper. If we want to win against paper, we have to choose scissors. And if we have to win against scissors, we have to choose rock. So that is our updated score table. And we can now just run this for part 2. Nope. And this is our updated score. So I said we don't have to figure out. Of course, we had to do it manually, but for 9 values, that's not a lot of work. So yeah, that's the right answer. You're 1 gold star closer to collecting enough star fruit. So that was the solution for day 2, or at least one possible solution. So here we have the beach just coming up now. I'm guessing we have actually sailed into this sort of lagoon or whatever. But someone over the forum in the Advent of Nim thread, of course, you can use to find other people's solutions. And someone mentioned my name here. Let's see. Yeah, I think I saw PMunch use this hack last year. So I just saw my name was mentioned. I didn't actually read this. So his solution for day 2, trying to be idiomatic. All procs are func. We don't have any procs. To indicate they are pure functions. That's a good thing. Usage of an enum for the shapes, which results in type safety and much improved readability, because rock obviously beats scissors, while A versus Z makes you think. That's a good point. In our code this year, I went with just annotating them with comments, which obviously isn't the cleanest way of doing things. Or it's clean, but if we do a refactor of this, then having actual types would be better. When the enum type is clear, you do not need the type prefix. So instead of shape.paper, you can just write paper. Easier to read. That is true. The converter from input string to shape is called toShape. It's a good convention. You don't really ever call a converter, so their name is kind of irrelevant. But 2x is a pretty common thing to call them. Game result is a range type to indicate it may have exactly 3 values. Oh, that's a good one. The encapsulation of the computation of a shape score leverages ORD for enums. Not quite sure what he means by that. Uses inc with 2 arguments to increment the score. Right, so inc with 2 arguments. I'm not a huge fan of that. I tend to use plus equals when I increment by more than 1. So his solution here is doing shape, game result. Interesting range there. toShape. Ooh, this is a nice one. I like this. A and X, or A or X, is rock. B or Y is paper. C or Z is scissors. Of course, for version 1, still carried that on for his version 2. And yeah, game result. Right. So basically doing a similar kind of thing to what I did. Shape score 1 plus the ORD of shape. Oh, very fancy. So ORD of shape would be the ordinal value for his shape enum. So that would be 0, 1, 2. Of course, you could assign, if you just assigned rock to 1, then you would have rock 1, paper 2, scissors 3 automatically. You wouldn't need this 1 plus. My game score takes in 2 shapes. Oh, this is a nifty little statement. So he creates an array of 0, 3, and 6, and then he immediately indexes that array with 1 plus and game result. So the game result returns draw or lose, draw, win as -1, 0, or 1. And then he has to add on 1. I'm not sure why he just didn't go for 1 and 2 and made this from 0 to... And of course, what you could do is also have this as an enum and use ORD on this enum as well. That would possibly be even cleaner. Because it's not obvious that -1 is a lose, 1 is a win. My score, shape score, plus my game score. Yeah. And then it goes through all the lines, turns these into shapes, and increments the score by a scoring function. So the thing here, so we do this kind of the other way around. We say we generate a table of all the possible combinations, and then we just loop through and just add those like look them up and add them. Of course, in our case, nym, so the nym implementation of a table is a hash table. So it will have to calculate the hash for every line over and over and over again, which is probably more work than doing this. Just doing the calculation for each line. So this is probably more expensive. But if the calculation for each score was harder, then this would be the cheaper solution. But for this one, the calculation is so cheap. I can't do Advent of Code sessions without lighting the fireplace. Yeah, it is a bit warm here though. The weather is pretty mild, actually, right here at the moment. But I'll keep it in mind for the future streams. Try to get a nice fire going. But yeah, today you can see the you can't really see it on camera. Maybe if I switch to this one. Yeah, you can see there's some Christmas decorations coming about. The Christmas pillows over there in the chair. So Christmas is definitely oh yeah. Here we have a Christmas pillow. I'm not sure where these pillows are even from. Right. Apparently, according to my girlfriend, they're apparently my exes. So yeah. Anyways, enough of that nonsense. We're here to code, not talk about Christmas. It's not even Christmas yet. It's Advent. Completely different thing. I mean, I guess if we were like pedantic traditionalist, we should have everything purple up until Christmas.
Fuck that.
I'm not sure if you could hear that. Yeah, part 2 does similar thing, just different scoring. Oh, my shape 4. Oh, okay. So we actually, right. So here he figures out which score. Fair enough. But what was this? This hack for last year. Whoops. Oh. Let's open this in a separate window. Last year, today's problem looked like a nail for that particular hammer. So, okay. Interesting. Strat, XYZ. Score, XYZ. Is an array. So these are the values for our chosen thing. This is a 3x3 array. Yeah, so this is basically the exact same thing that we're doing, but instead of creating a table of strings for all of the lines, they create a 3x3 array, and then they turn, wait, where even is, oh, yeah, no, this wasn't a hack of mine, but this is really fun. So he declares procedures A, B, and C, which takes strat as an argument, and strat is the enum X, Y, and Z. And what A given X does, it adds to the score this value, depending on what we choose, plus from our table 0, 1, or 2, depending on these, and what we the strategy that we chose, and it picks the correct score. And then they include the input. So include in nym just grabs a file and basically pastes it into our file. And so the same way we can have echo score, we could have AX if we just had a procedure A that took arguments that could match X, and enum like this matches this X. So this procedure matches this enum. So this is a call to this function with the X enum. So what they do is they actually just create functions. They create functions that make the input file valid nemcode, and then they just include this input file, which then just basically creates one program that just runs this. So you couldn't change the input after you compiled it, but if you recompile, it will grab the file and just execute the file as a program, which is a really interesting hack. But no, that was not one of mine. I'm not sure who came up with that one. That was a fun little hack. But yeah, that was everything for today. I will upload these to GitHub as usual, and I'll be streaming tomorrow's solution tomorrow. So then we will go further inlands, I guess, since we're now on the beach, or maybe we'll do more like camp setup. So yeah, that's it for today. Hope you enjoyed.